Alright, two more examples for us to work out here. We have sulfuric acid solution is added to solid aluminum oxide. So sulfuric acid, since it's going to be reacting with the aluminum oxide, is going to completely ionize, which means you're going to have two hydrogen ions and a sulfate ion. If the sulfuric acid was just in a solution by itself, you would only write the ionization of the first hydrogen, but since we're actually reacting it with something else, you go ahead and completely ionize it. Solid aluminum oxide, the formula for that, Al2O3. React these two guys. If you remember, metal oxides behave like bases. And so you're going to make a salt out of the cation of the base and the anion of the acid. So you'll have Al2SO43. And then the other product is going to be the oxygens plus the hydrogens, gives you water. So now all we really have to do is balance this. So we have two ALs, we got two ALs. So let's see, three sulfates, so let me put a 3 out here. We have 3 oxygens, so 1 oxygen here, so put a 3 there. And then we have 6 hydrogens, so 2 is what we have right now, but we actually need 6, so let's just change that little guy to a 6. And to be perfectly honest, my solubility rules are escaping me. I cannot remember if this guy is soluble or not. Let's pretend that it is, and since, you know, if we're pretending that it's soluble, then we're going to end up with 2 aluminum ions, 3 sulfate ions, instead of the compound put together. And so our sulfate ions become our spectators, and our overall reaction is 6 hydrogen ions plus the aluminum oxide gives us 2 aluminum ions and 3 waters. Again, I don't remember if aluminum sulfate is soluble or not. So y'all can look that up and see if I even needed to go through this extra step. If not, I would have just stopped right here before I crossed out the sulfates. Last example question. Carbon dioxide gas, CO2, is bubbled through aqueous sodium hydroxide. Sodium hydroxide is a strong base, so I can go ahead and ionize that guy. Sodium hydroxide. And what am I going to get? Well, looking at this, I have CO2 gas. This is a non-metal oxide. Non-metal oxides behave as acids. If you can't remember exactly how this is going to react, you can say, add a water to it. So if I added a water to this, I would have H2CO3. And so what I'm going to end up getting is sodium carbonate, which is soluble, so it would break apart into the sodium ion and the carbonate ion, and water. Balance this guy, 1 Na, 1 C, O3. We're not using this for balancing. That was just there to help you remember what product is going to be formed. So 2 O's plus 1 gives us 3. And then we got 2 H's, so we need to put 2 there. Now we have 4 O's. We got 3, 4, 5. This guy's making it odd. So put a 2, that's 6. Actually, they're both making it odd. Hang on. 4. Oh, no, we were good. Sorry. It's been one of those days. We got 2 O's, 2 O's. Here's 3 plus 1 gives us 4. So there's our balanced reaction right there. Cross out any spectators, which would be the sodium. And so we have carbon dioxide reacting with basic hydroxides, giving us the carbonate ion, which if I remember correctly, this is just going to immediately fall apart anyways, plus water. Alright, if you have any questions, you know where to find me. Adios, y'all.